Hello everyone. Today we're very excited to introduce our ICCV 2025 paper, PerLDiff, Controllable Street View Synthesis using Perspective-LayoutDiffusion model. Let's begin with the motivation behind our work. As we all know, the development of safe autonomous driving systems fundamentally relies on accurate perception of the surrounding environment. In recent years, bird's-eye view (BEV) perception has achieved remarkable progress, driving advancements in 3D object detection and BEV segmentation. However, these systems require large-scale datasets with high-quality 3D annotations, which are both expensive and time-consuming to obtain, as they involve scene collection and manual labeling. To address this issue of data scarcity, generative models have shown great potential. Instead of collecting scenes first and labeling them afterward, we can reverse the process, using the annotations themselves as controllable conditions to generate realistic street view images. This strategy dramatically reduces annotation costs, enables the creation of large-scale and diverse datasets, and helps improve perception models, especially for long-tail scenarios. However, as shown in the figure on the right, existing generative methods still struggle with precise control over scene layouts and object placements, leaving significant room for improvement. So what can we do? Our proposed method, PerLDiff, leverages perspective layout masks as geometric priors to enable fine-grained control during the image generation process. It achieves state-of-the-art performance on both new scenes and KITTI, significantly improving the detection and segmentation quality of synthesized street view images compared with previous methods. Now let's take a closer look at the core idea behind PerLDiff. Earlier works, such as BevGen, relied on autoregressive transformers to render detailed street scenes. More recent approaches, like BEV Control and Magic Drive, adopted diffusion-based frameworks such as GLIGEN and ControlNet, where the controlling information is integrated through a basic cross-attention mechanism. However, these methods mainly use integrated conditional features to influence the generation process. They do not fully exploit detailed geometric layout information, which is essential for achieving accurate spatial alignment and object-level controllability. To overcome this limitation, we propose PerLDiff, a novel framework specifically designed for precise control in street view synthesis. In particular, not only extracts semantic condition features from 3D annotations, but also renders perspective layout masks as explicit geometric priors. We then introduce the PerL-based controlling module, PerLCM, which uses these geometric priors within a PerL-based cross-attention mechanism to guide the generation of each object according to its condition. We integrate PerLCM into a pre-trained stable diffusion model and fine-tune it on our dataset. This allows PerLDiff to combine the powerful generative ability of stable diffusion with fine-grained geometric control, enabling accurate, object-level synthesis of complex street view scenes. We evaluate PerLDiff across multiple benchmarks, including multi-view 3D object detection, BEV segmentation, and monocular 3D object detection. As shown in the table on the right, PerLDiff outperforms previous methods on both new scenes and KITTI datasets. We also conduct ablation studies to analyze the contribution of each component in our framework. The results show that introducing road masking maps and box masking maps as attention priors significantly enhances performance in both 3D detection and BEV segmentation tasks. Furthermore, we use the images generated by PerLDiff to augment the training datasets for BEV perception models, such as BEV Former and StreamPETR, and observe consistent performance improvements across all benchmarks. In addition to controllability at the object and scene levels, PerLDiff can also control weather and time-of-day conditions simply by modifying the text input, further enriching the diversity and realism of the generated data. In summary, PerLDiff can generate high-quality, realistic, and controllable street view images, achieving both visual fidelity and precise geometric control. Thank you for listening. We hope PerLDiff contributes to the next step toward data-efficient and controllable street view generation for autonomous driving perception.